Hi everyone, my presentation today discusses about the encapsulation of enzymes in a more specific silica sol gel matrices. To begin with, the general outline of my presentation consists of a general introduction as to what is enzyme encapsulation, the importance of enzyme encapsulation, and then moving on to a more specific approach for encapsulating enzymes, which is using the silica sol gel method, the advantages and limitations of this method, and then wrapping it up with an overall conclusion. So in general, encapsulation of enzymes is generally the physical retention of enzymes in a porous semi-permeable membrane. And as we can see here, that the membrane could be in a form of a channel or a network, or in the form of a gel or a capsule which encapsulates the enzyme. Moving on, usually in industrial processes, the use of native form of enzymes is generally limited due to issues with their stability as well as reusability, which is a very important factors in industrial processes. So in general, enzyme encapsulation, it allows easy recovery as well as reusability of the enzyme, hence increasing their long-term operational stability. Obviously, it increases the economic viability of the process. The product recovery is much more easier using encapsulated enzymes from the reaction media, and the applicability of enzymes in these industrial processes using various solvents also is widened when one uses encapsulated enzymes. Several studies have also reported that the physicochemical properties such as pH as well as temperature stability is enhanced after encapsulation of enzymes. So, silica sol gel encapsulation involves encapsulating enzymes in a silica gel network which is built around the enzymes by its chemical condensation. So, as we can see here the image, this is the basic silica gel network encapsulating the enzyme, and it has it shows the substrate which has the access to the active site of the enzyme molecule and hence catalyzing the reaction. So basically this is the kind of a structure the sol gel has as a network encapsulating the enzyme chosen. So this in general is the sol gel methodology for preparation of silica gels. Normally, the process begins with the acid or base catalyzed hydrolysis of the silica precursor. For example, silicon alkoxide, an example being tetraethyl orthosilicate or tetramethyl orthosilicate, leading to the formation of silanols. These silanols then undergo condensation, forming siloxane bonds, which eventually forms the silica sol. And this condensation reaction has byproducts such as water and alcohols. Now the enzyme is usually encapsulated in the form of a suspension which is added in a certain buffer of a certain pH to this silica sol, helping it to undergo gelation. The gel is then allowed to age for a certain amount of time to undergo strengthening of the silica gel network, and is then subjected to drying, which eventually leads to the formation of a zero gel depending on the method used for drying. And this zero gel then contains the silica gel powder which has the enzyme that is to be encapsulated. Now we can see that the water and the alcohol is a byproduct of this reaction. Moving on, there are several advantages of this method. Firstly, it's a fairly easy method to prepare. Secondly, the conditions involved in this methodology are mild. Example being, it's a room temperature method. So this is a very important factor when one is encapsulating biomolecules such as enzymes or proteins. The silica sol and the silica gel is chemically stable, so it doesn't have any side chain reactions or it doesn't react with the enzyme. It has a high porosity, so sufficient access for the substrate to the enzyme, and then obviously it enhances the enzyme activity, stability, and most importantly the reusability, which is a very important factor considering the economics of the process using enzymes. Moving on, this method also has certain limitations. The first one being that it has been seen that over time the gels may undergo excessive shrinkage, which leads to brittleness and eventually cracking. As mentioned earlier, alcohol was a byproduct in this method, and excess of alcohol production can definitely denature proteins or enzymes that are encapsulated. And also, due to the compact structure of this network, there are some mass transfer limitations associated. So, overall, in conclusion, this further research could definitely contribute to development of an efficient method for encapsulating enzymes, and the silica sol gel method would has potential in broadening their scope for use in several industrial applications. In the end, I'd like to thank all my reviewers, Dr. Ngadi, the TA, and of course my supervisors, and I'm open to any questions that you may have. Thank you.